كيف حالك؟ إن شاء الله تمام. نشوف الأسئلة مع بعض الحين. أول شيء هذا البارت رح ناخذ الحين على ال PDF هنا. قال لي في أول جزئية consider the curve given by the equation 2x minus 3 plus cosine determine the concavity. concavity يعني يريد second derivative. فأول شيء أقول له أنا 2x minus y equal 3 plus cosine y. First derivative. First, let me simplify it. So 2x minus 2y equal 3 plus cosine y. So let me do first derivative. So the first derivative is 2 minus 2y prime equal 0 plus أو minus يا ربي minus sine y times y prime. This is as a chain rule. Okay, now we want to put y prime on a side, so it's going to be minus 2y prime plus sine y prime equal minus 2. So in this case we will take y prime as common factor, so y prime equal sine y minus 2 equal minus 2. So in this case, or we can continue because I don't want to simplify it, just want to check the concavity. Okay, so minus 2y prime plus sine y prime. We'll do another second derivative, which is minus 2y double prime plus the sign is going to be plus cosine first with derivative of second plus second with derivative of first, which is cosine y prime equals 0. Okay, so in this case I need to evaluate y prime alone now. So let me just put the y prime. Let me take this step. Put it down here, and let's put this in the term y prime. So your y prime is equal sine y minus 2 equal minus 2. So in this case y prime equal minus 2 over sine y minus 2. That's y prime. Okay, so if you want to check the concavity, in this case y prime should be, yes, so y double prime bracket cosine y minus 2 plus y prime square cosine y equal what? 0. So y prime it is minus 2 over sine y minus 2. Minus 2 over sine y minus 2 في cosine y equals 0. In this case, this is negative. If we shift it, it's going to be positive. So y double prime is equal to positive 2 cosine y over sine y minus 2 all over cosine y minus 2. So it's going to be two cosine y all over sine y minus 2 في cosine y minus 2. This is y double prime. So if we want to test like any value between pi over 2 and pi, let's put 0 as an example. So 0, 2 times cosine 0, 1, which is 2, sine 0, 0, that's, I mean like the y, because he's telling me that y is between negative pi over 2 and pi over 2. So 2 over sine 0, 0 minus 2 minus 2, cosine 0, 1, minus 2 minus 1. So minus 1 times minus 2 is going to be 2. 2 over 2 is equal 1. The answer is positive, so greater than 0. Greater than 0 then means the concavity is up. It means that the point is minimum. So the concavity is what? Up. So far as this one, hope the assignment is correct, because some questions in the assignments might be wrong. This is the first one. Let's go for the next one. The next one is telling me that the following question contains two statements. Statement 1, the normal of the curve is this. So the normal of the curve means I need to derive it and evaluate the point. So the equation is x squared plus 2xy plus 2xy, okay, minus 3y squared equals 0. Derive it. Minus 3y squared equals 0. Yes. Now we want to derive it. It's going to be 2x plus 2 bracket first with the second product rule plus second with the first plus y minus 6y y prime equals 0. So 2x plus 2xy prime plus 2y minus 6y y prime equals 0. So in this case, يا طويل العمر, we will take y prime as common factor, the remaining 2x minus 6y, okay, and which is equal minus 2x minus 2y. So y prime at the end, it's minus 2x minus 2y all over 2x minus 6y. Now evaluating x and y, x is a 3 and y is negative 1. X is a 3 and y is negative 1. So minus 2 times 3 minus 2 times negative 1 all over 2 times 3 minus 6 times negative 1. So the answer is negative 2 times 3, negative 6, plus 2, negative 4. And 2 times 2, 2 times 3, 6, 6 plus 6, 6 plus 6 is equal to 12. So the gradient is minus 1 over 3. That's for the tangent. For the normal, the gradient is 3. Let's check the gradient in the normal equation. It's true. But let's check it. Yes, it is 3. Correct. But still, if you want to write the equation of the gradient, the normal, we need to write y minus y1 equal gradient x minus x1. So it's y minus y1 which is minus 1 equal gradient 3x minus 3. So it's y plus 1 equal 3x minus 3. So y equal 3x minus 3 minus 1. So y equal 3x minus 4. 3x minus 4, which can I see that it's not equal to 10. The gradient is correct. The equation of the normal is correct 100%. But the problem is I'm having here with the 10. The 10 is wrong so far. Because yes, so far the gradient is correct, but the point, oh yeah, I made a mistake, by the way. See, this is, my dear, 3 times 3 it's 9. Yeah, see, sometimes I make mistakes. Yeah, why not? So it's minus 9 minus 9 minus 1, which is equal minus, yes, so y equal 3x minus 10, 100% correct, yes. Both statement correct, yes. Both statement correct. So it should be both statements are true. Number 1. This is for the first sheet that you sent already to me. Let's check for the second sheet. Here it's rate of change. A stone dropped in a pond, okay. Send out a circular ripple, okay, whose radius increases at rate 4 feet per second. So the R is 4 feet per second. That's R. Find the rate of which the circumference is increasing. First of all, he wants dc by dt, which is equal dc by dr times dr by dt. Okay, so first of all I need to calculate c is equal to by r, differentiate that, which is dc by dr is equal to by. So easy way. So dc by dt, the rate of increasing of circumference, is equal to by times the number that he gave it to me, that dr by dt, which is equal to 4. So the answer is what? 8 by, which is meter per second, or feet per second, sorry, it depends, yeah, feet per second. That's the circumference. Now, after 12 seconds, how rapidly is the area enclosed by a ripple increasing? So after 12 seconds, so we want to check that area is equal by r square. So and I'm having, yeah, which is dA by dr is equal is 2 by r. Yeah. You know, actually we don't want to make it the rates of change. Maybe we can do it another way. So if I'm having that 4 feet per second, so after 12 seconds, how many feet the radius will be? Yes, it's easy. For part B, it's easy. Area is equal by r square. I don't know r. So I have the increasing of dr by dt, which is 8. Is it 8 or 4? 4. It is 4 feet per second. Yes. So that's the dr by dt, 4 feet per second. Yes. So after 12 seconds, 12 times 4 is going to be 48 feet. That's r. So area is equal by times 48 square. Get it in calculator, and that's it. And remember, feet square. This is for this question. Third question that you sent me already. Evaluate using integration by parts. integration by parts. Okay, first of all, we know that algebra it's becoming like this. X minus 1 e to the power 4x. So this is going to be that that's dv. So I want to differentiate x minus 1, the answer is 1, and integrate e to the power 4x, which is e to the power 4x over 4. So the answer to this is x minus 1 times e to the power 4x over 4 minus the integration of e for x to the power 4 times 1. Okay, so the answer at the end is going to be e to the power 4x over 4 times x minus 1 minus integration of this is going to be e 4x plus 1 over 4 times 4x plus 1. Okay, or wait, no, if we want to integrate that, I need something, the differentiation of this. So I multiply it by 4 over 4, integration by 4 over 4, then I can integrate it normally. 4e4x, yes, since the differentiation is outside, then I can integrate it. So the answer is going to be at the end e4x over 4 x minus 1, so minus e 4x plus 1 over 16 times 4x plus 1, of course, then at the end plus c. That's the integration. Hope, because I didn't recall the way, but this is the way, yes, as it is. So it's u times v minus the integration of v times u. Just let me check something while I'm doing this to you. If I'm not wrong, integration by parts. Integration by parts. Just want to check the rule. Yes. Integration u times v minus integration v times du. Yes, exactly. So that's the answer for the second question. Hopefully, yeah, that's it. So integration of 4x but I can't remember the integration of 1 second. What if it's integration of x? Just 1 second. I want to check something here. Integration. Yeah, I did a mistake here. Yes, because I cannot remember the rule. 1 second. So it is only this part. Yes. Again, the integration of, yeah. So the answer is, yes, exactly. It's 1 over 16 e to the power 4 x. Yes, that's the answer. and then we can take it, simplify it. We can take a to the power 4 x over 4 as common factor, who's remaining x minus 1 minus 1 over 4 plus at the end plus c. Yeah, that's the part. Okay, sorry for the confusion, but I need sometimes to remember the rules. That's it. Yeah. Now for the last question that you sent for sketch, I'm just gonna do the sketch. Hopefully that it's correct, because there's a procedure to do sketch. Okay, that's your question, ya Zubair. So let's put it there. You want to sketch the cube. See, the drawing of the cube is always going to be in that way. But since it is cube, it should be that way. Let's check. That's the normal graph. But let's check. It's x cubed plus x squared minus 5x plus 2. So as I give it to you, the Desmos, you'll go to Desmos. This is the easiest way and the fastest way you can submit. It's x to the power 3. Can you see? It's x to the power 3. So let's make it precise for you more. So I want to make it more precise for you guys. 1 second. Yeah, so it's x cubed. Next, it's what? Plus x squared. Plus x squared. Plus. So the graph changed now. Plus x squared. Okay. Plus minus 5x plus 2. Minus 5x plus 2. Minus 5x plus 2. This is the graph of it. After you finish, you can take screenshot. No, not like this. It's card. You can take screenshot. Save it. That's the drawing. Okay, and if you want to solve it, you can tell your mister that you took like intervals x and y, starting from -3, -2, -1, 0, 1, 2, 3, 4, and then you put the answer. You plug the x every time and you put the answer here. What do you mean, mister? It means x cubed plus x squared minus 5x plus 2. So every time this is -3, you put it here, put it here, you put it here, you put it here, then you find y. Okay, just remove the arrows. Okay, then -2, you evaluate it, then you get the answer of y. Same story for -1, plug it, then you get y. Same story for 0, you plug it and you get the answer, and so on. Thank you very much. Hope you're doing well. Thank you and best luck.